So let's introduce the gravimetric data acquisition and outweigh correction. For the gravimetric surveying, we are considering many kinds of parameters, and so we have so many applications for geophysicists, like detection of salt diapiris, or create raster mapping with gravity gradient or Bouguer anomaly. So we have also to create a density model with salt and model salt. So we have also to integrate with this model with seismic reflection data to correlate the seismic interpretation with the seismic model to the other geophysical data like gravity survey. So what do you need to consider in gravimetric data acquisition? You need, as just said, to consider much more parameters like geographically position, topographical factor, environmental and temporal factors, instruments factor, survey design and data acquisition factor, geological factors that can be influenced for measured data requiring correction or other else. So when we are talking about the environment and temporal factors, we are to consider the Earth tides. The gravitational pull of the Moon and Sun can be causing in some periods of the year the variation of gravity field, which can be around this value up minus or up 0.3 milligal. These tidal effects must be corrected typically by the reoccupying base station or using predictive methods. Instruments drifts. Some instruments drift like gravimeters, especially relative gravimeters are sensitive and mechanical instruments, so we have also to consider the characteristic of instruments and the drift can be have. So we have also the external parameter like pressure, temperature, humidity and vibration. For temperature, humidity, fluctuation in temperature can affect at the instrument's component, leading to inaccuracy reading. By high humidity can also be tremendal, and instruments should ideally be operated in stable environment condition. For the atmospheric pressure, while usually minor effects in land surveying, change in atmospheric pressure can have a subtle influence on gravity measurements, particularly in high precision or airborne surveying. Seismic noise, vibration, ground motion from actual source, microseismic or human effects can cause vibration that interfere with gravimeters readings. Careful site selection and instrument stability are also crucial. By the instruments factor, you can consider, for example, the type of gravimeters. If you are using absolute gravimeters, you can make a measure with absolute value of gravity, high accurate by time consuming and less portable. The relative gravimeters measure the difference in gravity between the two locations, more common for survey due to their portability and faster measurement. The calibration. For the gravimeters need to be regularly calibrated to ensure that the dial reading are accurately converted to proper gravity unit. The sensitive and the prediction, the instrument's ability to detect small change in gravity sensitive, and they consist of these measurement precision are paramount. Stability and leveling. The gravimeters must be perfectly level or stable during measurement, and any tilt of moment can introduce error like the drift, or in leveling we have a change in dip and slip. We have also the riding procedure, and careful reading procedure are essential, and so this is a human reading. We are asked to consider the geological factor and geographical factor that can require correction, like for example the latitude, because for the gravity natural increase from the equator to the poles we have some increase of gravity because the planet is not a sphere but it is like a geoid. The elevation as distance from the Earth's center change, so doesn't to the gravity. The free air correction accounts for the change in elevation of the measurement point relative to the datum. We have also to do the Bouguer correction. This correction accounts for the gravitational attraction of the rocks, mass between the observation station and the chosen datum. Is important also to understand the topography factor and projection, the scope of work and projection. The terrain correction, these accounts for local topography variation, hills and valley that are captured by the latest level assumption of the Bouguer correction. It is crucial in this area with significant relief. The subsurface density constant, yes, if you have for example a really constant density, the fundamental principle of water gravity survey is detect variation in the Earth gravitational field caused by lateral density contrast in the subsurface, understanding the expected density range of rock and also geological structure is essential for interpreting the acquired data. So in the next appointment we are to show you, for example, these types, the three types of gravity acquisition. We have airborne acquisition, terrestrial acquisition and satellite acquisition, both observe Terra or other planet. See you in next appointment.